All right, so for the first one, f plus g, you just need to add them, right? So 3x plus 10 plus x squared minus 2x plus 5, and then combine your like terms and decrease in degree order. The x squared comes first, positive 3x and negative 2x is a positive x, and then positive 10 and positive 5 is positive 15. Raise your hand if you got it right. Okay, good. All right, f minus g. So this time the order is important. I want to do the f first and then the g. So the f minus the g, which means that minus goes to all the terms that are in g. So this would be 3x plus 10 minus x squared plus 2x minus 5. And then you combine your like terms, so negative x squared, positive 3x, positive 2x is positive 5x, positive 10, negative 5 is positive 5. Raise your hand if you got that one right. Okay, good. All right, then multiplication. So this one I just need to multiply f times g. So first one, the first one's going to get multiplied by each one. 3x to the third minus 6x squared plus 15x. And then the second one gets multiplied by all three. Positive 10x squared minus 20x plus 50. And then combine your like terms. So 3x to the third. Negative 6 and positive 10 is positive 10x, or sorry, positive 4x squared. Positive 15x, negative 20x, negative 5x plus 50. How about that one? Still good? Okay. And then f over g, or sorry, g over f. So I would put g in the top, x squared minus 2x plus 5 over 3x plus 10. Before I do anything further, I want to make sure I set the restriction. So the restriction would be 3x plus 10 cannot equal 0. Subtract the 10. Divide by 3. And there's my restriction. X cannot equal negative 10 over 3. And then I would go back to my fraction, see if I can factor the top or the bottom to cancel stuff out. There are no factors of 5 that sum to negative 2, so that's not factorable. I would keep that exactly how it is. Ian?
What happens if your answer does turn out to be the restriction?
Then there's well, you won't get an answer, but if that was set equal to something, you mean?
Yeah.
Like if that was set equal to 0 and I solved it and I ended up, then I would rule it out. It would be no solution.
Oh, okay.
Yeah, but right now we're not solving these. We're just simplifying them. So there's no answer to that. Does that make sense? There's no solution to that yet because it's not an equation.
But which one are you factoring, the top and bottom?
You would factor either because you can simplify in either way.
Oh, that's just to simplify.
That's just to simplify it. Yep. Isabel? You sure? Yeah. Okay. All right. So then let's move on to this last example. Okay. This time it's f over g of x. So the f goes in the top. G goes in the bottom. Before I go further, set your restriction. So x cannot equal negative 4. This is my restriction. This time you can factor this, right? X squared plus 16 is x plus 4x minus 4. And then the x plus 4's cancel. And I would get just x minus 4. Questions on that one? Everybody's good? Yes? Okay. All right, so we started this on Friday. We did 1, 2, and 3 on Friday. And then 4 on Friday we talked about the composite functions, which is what this g of f of 2 is. That's how that's read. So for that one, I'm going to start by doing the f of 2. So I'm going to find f of 2. I'm going to go to the f, which is 4x squared minus 1. And I'm going to plug the 2 in the place of the x. 4 times 4 minus 1, 16 minus 1, which is 15. And then, since f of 2 gets replaced with 15, now I'm finding g of 15. So I take 2 times 15 minus 1, 30 minus 1, which is 29. And that is your answer. Okay, this is now given two different functions, f of x equals x squared and g of x equals the square root of x minus 1. Write each composite function and then state the domain of each. So I'm going to start with f of g of x, which means I take the g and I plug it into the f. So this one's going here. So f of g of x is the square root of x minus 1 squared. And what happens when you square a square root? It cancels out. So this is f of g of x equals x minus 1. So now I'm going to state the domains. So I can go back up to the top to state the domains here. Remember, domains, you're looking for two things. If a variable is in the denominator or under a square root. Are either of those two things happening with f of x? God bless you. No. So this is all real numbers. There is no restriction. How about g of x? Variable in the denominator? No, variable under square root. Yeah, so I set whatever's under that root greater than or equal to 0 because I can't square root a negative number. So x has to be greater than or equal to 1. That would be the domain for g of x. And then each also includes the composite function. Is there a restriction on f of g of x?
No.
No, there's no variable in the denominator, there's no variable under the root. Questions so far? Okay, now I do the same thing, but it's f of g, or g of f of x. So I'm taking the f and I'm plugging it into the g. So square root of x squared minus 1. Same domain on the initial functions, obviously that hasn't changed, okay? And then for this, I have to say x squared minus 1 has to be greater than or equal to 0. X squared would have to be greater than or equal to 1. And there's two values there, okay? When you have an inequality with a squared function, okay? Any number I plug into x, what's going to happen when I square it? It's going to become positive. So the only restriction here lies in between 0 and 1. So x has to be greater than or equal to 0, but less than or equal to 1. I'm sorry, not or equal to, just less than. Because it can be 0. Okay? So if I plug 0 into there, I get a negative number. I can't do it. If I plug in 1/2, I get a negative number. I can't do it. So my restriction for this is that x has to be greater than 0, but less than 1. Questions on any of that? Okay, so we're going to start it today so we don't have a full section to do tomorrow, okay? But this is 6.6. This is the last section that's going to get covered from chapter 6. And the last section that'll be on your quiz, which is Thursday. So quiz on Thursday is going to be 6.4, 6.5, no, 6.3, sorry, 6.3, 6.5, 6.6. So we're going to talk a little bit more about inverses, which we've done, but now we're pulling in function inverses. So there's two kinds of tests for functions. The first is called a vertical line test, and it's used to determine if a relation is a function. So if you're trying to figure out if something is a function, then you use what's called the vertical line test, which is if you can draw a vertical line through the graph of a function and that vertical line hits that graph at more than one point, the graph is not a function. If you're trying to determine if the inverse of a function is a function, then you use the horizontal line test. And the horizontal line test is the same except you're dealing with a horizontal line. So if a horizontal line passes through the graph at more than one point, then the inverse of the function you're looking at would not be a function. So to see if the one you're looking at is a function, you use the vertical line. To see if the inverse of it, you would use the horizontal line. And the directions will say, use the horizontal line test to figure out if the inverse of this function is a function. Okay, so it's pretty straightforward. So this is what they look like. Use the horizontal line test to determine whether the inverse of the blue relation is a function. Sure. So I'm looking at this graph. Okay, there's two functions on this graph, the blue one and the red one. And this time it's saying, figure out if the inverse of the blue relation is a function. So horizontal lines, I would draw horizontal lines through this graph. If that horizontal line, any of these horizontal lines, hits that blue graph at more than 1 point, then the inverse is not a function. Do any of those lines I just drew hit the blue curve at more than 1 point? No. So the inverse is a function. Yep. You could just go top to bottom, or you could look at it in your head, picture it in your head. If any horizontal line hits it at more than 1 point, then the inverse is not a function. The red one. So if I draw, let me do a different color so you can see a little bit better. If I draw a horizontal line here, is it hitting that red graph at more than 1 point? No. How about here? How about here? How about here? How about here? If any of the lines hit it, then it's no. So the inverse of the red graph, which is what this one is not a function.